We talked about the visual of even and odd functions. So if my function is the quadratic, okay, x squared, is it even? Yes, it is, because when I rotate it around the y-axis, it maps back onto itself. So it's you know this, the axis symmetry. It's symmetrical over the y-axis. What else is symmetrical over the y-axis? Apparently x to the fourth, which is a function that we're going to explore in a later unit. Okay, with no transformations. What isn't? X cubed. Okay, because look, when I reflect it, the green is the reflection over the y-axis. The red was the original function, not the same. Okay, but what x cubed is it's odd, because if I do a rotational, like 180-degree rotation around the origin, okay, it has symmetry around the origin. And some things are one and some are another and some are neither. So that's the visual of it. And that's one way that you really do want to remember. Even, and what do you notice about the word even and the functions that are even? What's x squared, x to the fourth? What do you think x to the sixth is going to be? It's going to be even. Okay, so that's kind of where I think where that comes from, is that when you're looking at x and just raising the exponent, the even numbers, just the parent function, no transformations, are even, and the odd numbers, x cubed, x to the fifth. In fact, take a look, x to the 1 is odd. If I rotate it, that's x to the 1, right? Y equals x. It is an odd function. Okay, it's not even. So that's one way to remember which one's odd and which one's even. Here's the algebraic thing of, so this definition, which you have in your notes already, I think. If you don't, you can get it later. What does this mean? So this is what we're going to explore just briefly right now. F at x is equal to f at negative x. Or f at negative x equals negative f at x. What does that mean? And some people get confused about this. It's actually kind of simple. If we think about it in terms of y equals x squared, it's 2 squared is the same as negative 2 squared. And that's what makes the quadratic look the way it looks. Because when I square 2, I get 4. When I square negative 2, I get 4. So whether I put in a positive or negative of the same number, I'll get the same value. That's what makes a function even. And if you think about the idea of an even, like symmetry around the y-axis, that makes sense, right? Whether I put in positive or negative, I'm going to go up or down the same amount. I could go down, but I'm going to go up or down the same amount. This is going to give you that symmetry. What does an odd function mean? Well, it means if I put in, it would look like this. So if it's f at x equals x cubed, okay, I put in negative 2 cubed gives me negative 8, and 2 cubed gives me 8, but positive. So my result of putting in negative or positive, it doesn't always have to be like when I put in negative, I get negative. Usually works out that way, but it doesn't have to, okay? But when I switch the sign of my input, I switch the sign of my output, essentially. Does that make sense? So they're both 8. One's negative and one's positive. And that has to be obviously for all values of x, not just for one that you happen to pick, right? That would make a function odd. Here's the algebraic look at it. So let's determine algebraically if f at x cubed is even or odd or neither. How am I going to do that? First of all, I'm going to do f at negative x. So I go negative x all cubed. Negative x all cubed is negative x times negative x times negative x, which is negative x cubed. Whoa. Negative x cubed, right? And then I'm going to do negative f at x is the negative of x cubed, which is still negative x cubed. So in this case, since, wait, I'm going to do a different color for that. Since f at negative x equals negative f at x, it's a little bit weird when you first see it, but it clicks eventually. Therefore, odd. And remember, if you don't fully understand this today, that's okay. Let's take a look at another one. So f at negative x is equal to negative x squared. So if you were asked to do this on a test, algebraically, this is what you would do. You would put negative x in here, okay? And I get negative x times negative x, which is positive x squared. So I've already done it, but I'm going to do this part anyway just to show us. Negative f at x is equal to negative x squared, which is negative x squared. So see how in this case, in the odd case, I did both tests, okay, and they were equal to each other. So it's odd. In this case, I did both tests, but this one was equal to the original function. So it's even. There's how you tell. And if it's equal to neither, like this one here, when you put negative x in, will either be equal to this, or it's neither. And neither is common occurrence. If you made up your own functions with random transformations, likely it would be neither. Okay, I hope you're at least kind of getting this. Let's do this one, f at negative x equal. This will be the one that maybe will help it click for some people, I think. So this is negative x all cubed plus negative x squared. So this is going to be negative x cubed, and this is going to be positive x squared. Is that the same as the original function? How can I zoom in anymore? Is that the same as the original function? X cubed plus x squared is the same as negative x cubed plus x squared? No, not the same. Let's try this. Negative f at x is negative x, how do I want to do this? Like this. Plus negative x squared, plus negative x squared. So this is negative x cubed minus x squared. None of those three lines are the same. That one, and that one are all different. Therefore, neither. Sorry, this one should be therefore even. X cubed plus x squared. Let's take a look. X cubed plus x squared. So take a look at that. See that? It's got a little bump there. I don't know how well you can see that. So let's check both. Neither of them, when I rotate one way and rotate the other way, maps back onto that original red function. So it's neither, like visually matches the algebra. So that's even and odd. Okay. So last thing, I'm not going to do the last three examples, but we'll do this one just to talk about. What about sine? We already saw it visually. Does anybody remember what it was? Even or odd? It's one or the other. It's odd. Okay. And so why is it odd? Because when I put in sine of negative x, I get negative sine of x. Right? If I make, so there's x, there's negative x. In the bottom quadrant, sine is negative. This is a different way of looking at it. You could do it with numbers and you'd see that it was true there too. If this is x, this is negative x. I'm talking about angles here, right? Don't think about coordinates. Same thing, sine's negative. So then what about cosine? Oh, jeez. Cosine of x. What is it going to be? Wild guess. Good. Why is it even? For a few reasons. It's even because it's even, but how can we determine that it's even? We can do that in a few ways. We can do it the same way here. So if I do x and I do negative x, well, cosine's positive in both of those. So what's this telling us? Sorry, it's telling us cos of negative x equals cos of x, right? They're the same. That's one way of looking at it. I could look at it this way. What if I repeat this back like that? Cos of x is the same as cos of negative x. There's negative x, there's x. They have the same y value. Symmetrical across the y-axis. Okay, I'm going to stop there.